Hello again. It's me. Surprise. This is Huff, your teacher. Remember me? I know, sorry. I'm very awkward normally in general, and being on video is even more awkward for me. So here I am. So I think that you've probably seen some vocab. If I've done my work correctly, you probably should see some vocab that you guys had about mapping and topographic maps. So you're probably like, okay, what is this? I wish I was there because there's some cool stuff that we can do. I don't know if I'll be able to set this up for you guys. Um, if you notice from my introduction, this is all on the same day that I've been doing this. Not that I don't change clothes, okay? Um, I'm not sure how I'll be able to set things up while I'm gone, but there's stuff that I'm going to try to do, okay? So one thing I would have really liked to do with you guys, and maybe you would still be able to do it, is to kind of make your own topographic map by making your own little mountain out of Play-Doh, which I have some. I didn't yet bring it home to my children. Well, the little one can't have that. So the idea of a topographic map is, how can we show that the Earth has features like mountains and valleys and rivers on a map? I mean, you can draw stuff, sort of. Like, I don't know, I've seen those little maps where people will draw like little triangles to be mountains and they look all cute. But how can we accurately show like mountains and hills and valleys on a map? That's a challenge, right? So those types of maps that do show what we would call relief or like mountains or features are called topographic maps. Here's an example of the state that I'm from. Not this stinky part down here. I'm from, let's see, it's like right there. I think it's actually the big one where it says Buffalo, New York. Yeah, you can't read that. Anyway, so what we're looking at in this map, it's a topographic map. We're able to see that New York has mountains. Part of what you can use to tell in this case is color. So like as we go from green to sort of a yellowy orange to this brown, we can see higher and higher mountains. So we can see in some areas there are some tall mountains in New York State. New York City is kind of low lying. See how it's a darker green? Like, I don't know if you've seen videos. When was it? Over the summer, where like the subways and stuff were flooding. Okay, we're out sticking out into the Atlantic Ocean here on Long Island. So this is like lower elevation, so that darker green is lower. We can see maybe a river cutting through here, like probably the Hudson River. And then over here we see two of the Great Lakes, Lake Ontario and Lake Erie. So this map shows, like I said, what we call relief, where there are mountains or valleys. Well, sometimes we don't have a map that's in color, so we need different ways to kind of show what's going on. How can we show, like, if I'm hiking, how can I tell how tall this mountain is or how steep the grade is if I'm driving or hiking or whatever I'm doing? Well, there's a way that we can make these maps, these topographic maps, and I'm going to kind of show them to you so you can familiarize yourself with them. Because again, in this course, we're going to talk about landforms, how the Earth changes shape and form. So knowing kind of how we would depict that in a two-dimensional picture is kind of important. So let's take a look. My head's in the way over there, sorry. So you have some topographic map vocab. Some of these words are on there. A couple of them are not. So this, you'll see this notes. Couldn't think of the word. Yeah. Anyway. So you'll see these notes up on Google Classroom. Okay, well, what's the deal? If you don't see the word in the vocab, I might have fixed it. Then make sure you just add them. So just double check that you have these words in with your vocab. I'm pretty sure that I fixed it, that they're in there, but just in case, please make sure you have these words. So these are kind of the words that I'm going to be using as we talk about things in topographic maps. You'll see from other people too. There's not a ton of good topographic map videos, surprisingly. But we're going to be looking at maps that have these lines. And each line, if it connects, is going to show you this is the same elevation. Kind of like when you look at a weather map, or if you've ever seen the weather on TV and they show like, here's a line and all this is like 65 degrees and all this is like 55 degrees. We call those isolines. On a weather map, they're isotherms, same temperature. So these contour lines, if they connect, they mean that they're all the same elevation, the same height above the ground. So by looking at these maps and having these contour lines, we can tell, okay, we're going uphill or downhill. This elevation is increasing. Here we see a mountain. Here we see a valley. Here it's kind of flat because the contour lines are kind of really far away. If we talk about elevation, we're talking about how high up from sea level, so like kind of like the base level. A gradient is how quickly these lines change. So if the lines are super close together, we're talking about a really steep mountain. If the lines are very far apart, they might be a low, like it might be the kind of hill I could hike up. Something really like that's going to change very easily. If you see a hatchet line, it just means like a line with, I will draw it for you because that will make way more sense. Hatchet line looks something like this. Okay, those are little hatch marks. And that's going to kind of show you where it's going to go down slope. So if they're all pointing like in the same direction, I just tried to draw some, but if they're kind of pointing all in the same direction, it's showing you which way is down. Like, so I'm going downhill. If you're talking about a profile, like not the profile pic, but like, a profile, it's like kind of like a side view. So if we could look at like it sideways, topographic maps, we're usually looking from the top down. And then here's a little formula that you're not going to need to memorize like that. But gradient is just the change in elevation. How quickly are you going up over the distance? So again, if like, you're going up like a steep, tall mountain, well, it's a very steep, large gradient because we have a big number on top and a little number at the bottom. Where if you have like a low hill, well, you might have a very little change in elevation over a long space. So you'd have a small number or maybe a decimal number. So there's just some basic terms for that. So you can take your time, you can pause, look at that, look at the vocab list I've given you, and kind of try to take some of that stuff in. I really, really recommend if you're like, I have no idea what she's talking about. You have the computer, it's in front of you right now, or you wouldn't be seeing me. Look up some of these words and just say explained for students. Look up a video of some of this stuff. Some people will explain it much better than I can. Like, I'm not terrible, but I'm not the best at explaining everything. So there's probably somebody who's like an expert in topographic maps who you could watch and they would explain it and you might get it in a different way than you'd understand from me. So let's take a look at these isolines. So any isoline, you see how these lines are going to connect the number 24? So, hey, you know what's funnier than 24? 25. You guys probably don't want anyway. Okay, so we're looking at isolines. They're going to connect even numbers. So here's a 28. We don't see any other ones. Here's a 26. We don't see any other ones. Here's 24. They're going to connect all the dots that say 24. Well, there's not a dot here. 24, 24. How did they know to go this way? Well, 24 must be somewhere in here because we have a dot that says 22 and one that says 25. Well, what are these dots then? Well, someone measured how high off the ground the elevation was at these different points. That's why you might see those like surveyor guys kind of out on like the side of the road and stuff. They take elevation as a measurement. So isolines are going to connect elevation that's the same. So they're going to connect the dots through the same numbers. So if you take a look here, we can see, like I can tell just by looking at this is a hill. How do I know? Well, take a look. We've got all these numbers here. We've got these connecting about 90. It doesn't look too super correct, but pretend like you don't see that. We have these numbers connecting the number 90 all the way through here. Then I have a 93 and a 95. So that looks like that's the highest. And then all the way down here, I've got 50, 45, 40. So it looks like I go from 40 feet or 40 meters to all the way up to 95 meters. So if I was going up this, it says Pine Street. Well, I'm going up a hill. So that's how we can kind of use these isolines to tell where there's a hill. Maybe if you've ever been hiking or seen something like that, you might have seen a map like this. I bet I haven't tried to look, but I bet there's a feature on like Google Maps that would let you turn on something like topography. They would probably just give you like street view or something, or like satellite view, and then you'd be able to kind of tell. So isolines, they're lines that connect points of equal value. They can form loops like this, or they can kind of form lines depending on how far you're zoomed in. Okay, like I'm kind of zoomed out on the top one looking at a hill. Here, maybe I'm zoomed in really close, or these numbers are very close together, so maybe this is very flat, a very flat area. So you guys can look at this because I know my head's blocking it. But it's just saying that each line connects equal values. And if there's not a dot that has that value, then you go in between trying to like make sure, like this line, the 24 line is closer to 25 than 22 because the number 24 is closer to 25. So what's the purpose of a topographic map? It's to show height or elevation above sea level. So here we're looking at a section. Remember, there's those hatchet lines to kind of help us understand where uphill and downhill is. And so here we're reaching the top of this hill. So they're just going to show us elevation. And sea level, what we would call sea level, is always has an elevation of 0. So what about contour interval? What does that mean? Well, it's the value between two of these lines. So the contour interval of this, let's try to figure this out. So here's a line that says 20, 25, 30. The contour interval must be 5 units, okay? In science, we're not supposed to have like naked numbers. But it doesn't tell us if this is feet, meters, miles. Miles would not be miles. But it doesn't tell us. So we're just going to say it's 5 units apart. What about this one? We've got a 20, and then we've got like a non-labeled line of 30, a non-labeled line of 40. Why don't you take a look? You can pause the video, take a look at these, the rest of these 2, 3, and 4, and see if you can tell what the contour interval is for each of these. And then see if you notice anything strange, maybe about number 2 that you might want to ask about. Did you actually pause the video? Or are you just waiting for me to give you the answer? Look at it. I bet you're like, oh, this is easy. Once you look at it. So map 2 is also 5 units. You might have noticed something weird about map 2 where it kind of goes down to this little line here. This is probably a river, this like A to B line. Usually like when contour lines kind of connect like that, they're kind of going like towards a river. Map 3 up at the top here is also 5 units, even though this one is not labeled. Okay, it still is a contour line, so each line represents 5 units. And then map 4 is the same way. There's just a non-labeled line in between. So it doesn't matter like what they label, it's like what the line is, okay, the line value. So spoiler alert, they're all the same. Okay, now let's take a look at elevation. Elevation is the height of wherever you're looking at compared to sea level. So like here we have like Aurora Hill, the peak is 533 feet in elevation. Holland Hill, it doesn't give us the exact peak, but near the top of Holland Hill, it's going to be 550 feet. Okay, so why don't we kind of take a look? It's telling us contour interval is 10 feet, and they've labeled these dark lines. Okay, so they've labeled a line at 500, they've labeled a line at 550. They're telling us our contour interval is 10 feet. So that means each of these lines is worth 10. So this would be 510, 520, 530, 540. Look, 550. Makes sense. So up here near the peak of Holland Hill, it must be about 560 feet above sea level. So why don't you take a minute and pause the video, see if you can figure out what the elevation would be of point A, point B, point Y, and point Z. And we're going, here is a lake, Lake Lackawanna. So clearly, like these are hills. As we go toward the lake, you can kind of imagine we must be going downhill, down towards where a lake would be. So we can see this way the numbers are increasing, so this way they must be decreasing. So pause the video, see if you can find the elevation of these on your own. And then we'll go from there, and I'll try to help you guys. If you're like, I don't understand, I'll try to explain it to you. Actually, pause the video. For real, like pause it and see if you can get it. Did you pause the video? I hope you did. So point A is 520 feet. How do we get there? Well, here's my labeled line, 500. Okay, my next line, I know the contour interval is 10. So the next line must be 510. So this ISO line right here must be everything at 520. So this point must be 520 feet. So hopefully point B was easy. It's 550 feet. It's on a labeled ISO line. So hopefully that's easy for you guys. Now let's look at point Y. So we have 500. We're going downhill. So it's 490 feet. Remember, our contour interval is 10 feet. It's one below the 500, so it must be 490. And see, do you notice how the contour lines kind of point or go towards a stream, maple stream? You'll see that in it's kind of a hint if it's not labeled that there's a stream there. And then point Z. Well, we're at 500. 510 would be the next ISO line, and then after that we have 520. Okay, that's how we do it. Hopefully for you guys, you're like, oh, that's not so bad. If you take a look down here at this little key that I'm circling with my mouse, this tells us kind of the size of the map, so you can kind of like see how far we're going. So if you kind of put that up there, you could see that, you know, going from Lake Lackawanna up to something like Girard Hill is going to be, oh, 8 or 9 miles. That's how you can kind of tell distance on a map. That's our scale. When the lines are close together, like take a look where my mouse is right here, that indicates it's steeper land. So trying to climb up Holland Hill this way would be hard because it's pretty steep. We can tell that because these contour lines are close together. Like for example, we're going up 10 feet here in a very small distance. And remember, our scale says we're about this much. You can see down there is 6 miles. So it's not like it's like a straight up the side of the mountain, but it is pretty steep. What about maximum or minimum elevation? Let's take a look at that. So to figure out the maximum elevation of a hill, we figure out what one contour line higher than what is shown would be. So like, what's the maximum elevation for Holland Hill? Well, we see 550 here. There's a contour line for 560. And one line higher in our contour interval would be 570. So could Holland Hill be 570 feet tall? No, because then there would be a line there. So the maximum height we could find at Holland Hill would be 569 feet. In this case, in some cases, they'll actually put a little peak and tell you the elevation. So like take a look at Aurora Hill. So we've got 500, 510, 520, 530. The maximum height, since there's not a 540 line, would be 539. But it's not. It tells us that it's 533, and this is where the highest point is, the peak of Aurora Hill. So the minimum elevation would be, okay, well, we see the contour line is 560. So around here it's 560. So the lowest Holland Hill would be 561 feet. So the peak of Holland Hill is somewhere between 561 and 569 feet. How do we know that again? Well, there's a contour line that shows it reaches up to 560 feet. It's on there. But there's not a contour line for 570 feet. So it's got to be somewhere in between there. I think of it like a graph almost. Like, you know, if you're trying to like graph something, your number has to be in between those two numbers somewhere. So what about a depression? Not that kind of depression. Okay. A depression is an area that's lower than anywhere else. So like it's like a hole almost. So on a topographic map, see right here, they're marked with small inward lines. They're called hatchet lines. Do you see the hatchet lines? They're pointing inside, which is showing, hey, we're going downhill. So this is kind of like a volcano, not really, but like there's a depression at the top of this mountain, a hole inside. So here's what it would look like at the top on a topographic map. Here's what it would look like in real life. Okay, so how else can we tell that it's going down? Let's look at our ISO lines. 280, 290, 300. Oh, we have another line at 300. So maybe it kind of went up, like see how it went up? It didn't get up to 310, because if it did, we would see an isoline at 310. So maybe it went up a little bit, then it went back down to 300, and we're showing here's where like a depression starts, and we've got our hatchet lines pointed in. So that's kind of what I just kind of talked about right here. So you want to make sure you add those little lines to show we're having a depression, we're having a lowered spot. So you'll be able to see those on your notes, but that's kind of like what I kind of told you guys. So what about rivers and streams? Well, this kind of makes sense. I hope. Rivers are always going to flow downhill. You don't say. Yeah, they're not going to go uphill. So they're always going to go from high to low. If you had biology with me, it's like osmosis. Remember, molecules are going to go from high to low concentration, but they're also going to go from high to low elevation. Look how easy that is to remember. When a river goes through a contour line, it's going to kind of form a V shape. So if you take a look, I'm going to put my mouse here. You're like, Miss Huff, that doesn't look like a V. Well, turn your head upside down. Okay, but they're going to always kind of point towards the river like this. Okay, it points to where the water's coming from. So kind of take a look at Maple Stream right here. You can kind of even use your finger to trace the V as it crosses over. And the V's point to the top of the map. So Maple Stream must be flowing downhill from Holland and Girard Hill all the way down to Lake Lackawanna. Okay. And then it's important too to kind of remember, let's use directions. I know I forgot to say that. But it's telling us north is that way in this map. So it's going down and that way. Sorry, it's backwards for me on the camera. So that's southwest. I know you can't see. You'll be able to see when you look at the notes. Is it also moving downstream? Yes. Okay. So let's look at the topographic profile. So what we can do if we have a topographic map, we can actually, if we trace a line through it, what we can do is then kind of draw out what that hill would look like in a profile. So it's the profile is the side view. I know, like profile pictures, people never take a side view of their face. It's always like front, and then they've got a filter on with a little kitty nose, or like, you know, the big eyes and stuff and all the fake makeup. You don't need all that. You guys look fine the way you are. You don't need a filter to make you look a certain type of way. That's my good advice for the day. So profiles show hills, valleys, and how steep or flat the land is. So let's look at how to create a profile like this second drawing from a topographic map. Okay, so you get like a piece of scrap paper and put it between the two given points. Make a mark at the scrap paper to show where each contour line is. So do you see how these dots show where each contour line crosses okay, re-explain. So I don't have editing software. And even if I did, I would probably not be great at using it. Do you see how each of these dots represents where that line A to A prime crosses an isoline? I'm going to try to drag my mouse down. I would really rather point with my finger or point on the board. But you can see that each point is where the A line crosses an isoline. So there's one at 140. There's another one at 140. Here's the one at 130, 120, and 110. Okay. Then you label them with the elevation. All right. Then you line your scrap paper up with the little grid and then put a dot above each one, kind of like that. And then connect the points. Okay. So you kind of have to make it, it's almost like making a graph, honestly. And so you connect the points. When 160, it just makes sense, would be at the top. And then as we go down, it's going to be near the bottom, kind of like a graph. Oops. And then if they have the same elevation, well, then the curve should kind of connect them. Okay, so like they should be connected. It might go, like this might go up slightly above 160 because we're at the top of a hill. We figure here at 140, maybe it goes down a little bit, or at this 130, it goes down a tiny, tiny bit. Maybe at 140, it goes up a tiny, tiny bit above 140. So that's how you're going to create a profile from just a topographic map. So take a minute, look at these different topographic maps and these profiles. See if you can pause the video and match up which one goes with what, okay? So like if you look, for example, this one looks like it's got 2 hills. I know because we've got, isolines connecting these, and it looks like it's going up, and here it's going up. Okay, so why don't you take a minute, pause the video, and then I'll show you guys what they actually are. So don't spoil it yet. Try to figure it out for yourself. You are smart. Use your brain. Don't just wait for me to tell you. Try it yourself. Did you try it? Please do it. Okay, I'm going to tell you. I'm going to show you. Here's your answers. So one is B. How do we know? Well, we've got a low hill and a high hill. And so see how we've got we've got more of our contour lines here and fewer here. Let's just say it's 10, 20, 30, 40 feet. Well, here I've got 10, 20, 30, 40, 50, 60, 70 feet. It's almost twice as high. Okay, number 2 is E. We're looking at like a straight up mountain. There it is right there. So you can kind of see why each of these is the one it is. Hope that can help you. What I would like us to do maybe is eventually we'll get some Play-Doh and stuff. We'll like cut the Play-Doh with some like dental floss, and we'll make isolines, and then you'll have to trace them, and then people can try to see if they can recreate your mountain that you made just from your topographic map. That would be fun. So what about gradient? How do we tell if we've got a steep mountain or if we're just kind of going up a gentle hill? So what's the gradient formula? It was at the beginning. It's the change in the field value, so it's the change in like elevation over a distance. So in this case, our distance, like our key shows us how big 3 meters is. So we can kind of measure this. And then our contour interval is 10 meters. So what does gradient mean like in words then? It's how flat or how steep the land is. Like, are you going up like a mountain, or is this like a gentle hill? And that means how high up you're going over a distance. So like a mountain, you're going up really high in a small amount of left-right distance. You're going up, down a lot, and you're not really going left, right a lot. But like something like a hill, you're going to be walking like left or right, and you'll be going up a little bit as you go up that. So let's take a look at B through D. How can we find the gradient of that? Let's look here. We've got 50, 60, 70, 80, 90, 100. So we're going up a hill. I can tell because of the contour lines. I counted. I know my contour interval, and they're labeled. It's labeled on there. So hopefully that'll be easy. So we're going up 50 meters. And then we're going to have to kind of measure with like a ruler, or you can use your finger. It's not really super accurate, but you can measure how far that is. It's probably about 2 kilometers. So you're going to plug that in, the change in the field value. So it's 50 meters. Sorry, I did the math for you. 100 meters minus 50 is going to be 50 meters over the 2 kilometers that we're going up the hill. Now, if you look between like D here and right before C, we've got a lot of space between our contour lines, meaning it's kind of a gentle slope, okay? 2 kilometers is pretty far. And if you're only going up 50 meters, it's not that steep. So our gradient is you're going up 25 meters for every kilometer you walk or drive up this hill. So that's how you figure out gradient. It's basically how high up you go over a distance. And remember, contour lines that are close together, like over here where it says Crow Mountain, spoiler alert, it says mountain. When they're closer together, we have a steeper angle. When they're farther apart, it's a more gentle slope. So that's it. That was a lot of information about mapping and maps. So you guys will kind of look at that and kind of get an idea about it. But that'll help us when we talk about like landforms and things and how things are formed to understand how do we measure that? How do we look at that? So I hope that helps you guys. I hope like if you come across a map with some contour lines on it, you'd be like, oh, I have an idea of what's going on in this map now. So Yep, I hope that helps. I'll see you guys soon in the next video when we talk about not this. All right, bye.